Okay, so today we're going to prove the alternate interior angle theorem. And this theorem states, when two parallel lines are cut by a transversal, the resulting alternate interior angles are congruent. Okay, so we have a specific diagram for this theorem here. So for the diagram, if line AB is parallel to line CD, and EF, right, is a transversal that cuts across AB and CD, then angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, aka the alternate interior angles are congruent. So let's go ahead and start the proof. So the way we're going to start this is by using the corresponding angles postulate, okay? And this will be useful for all these types of proofs, okay? So by the corresponding angles postulate, it tells us that it's an if and only if statement. So we have AB parallel to CD if and only if all the corresponding angles are congruent. So angle 1 is congruent to angle 7. Angle 5 is congruent to angle 4. Angle 6 is congruent to angle 2. And angle 3 is congruent to angle 8. So this is an if and only if statement. So if I have these two lines are parallel, then I have all the corresponding angles are congruent. And if I have all the corresponding angles are congruent, then I know that the two lines are parallel. So the next thing I'm going to use is the vertical angle theorem. So by vertical angle theorem, I know that angle 1 is congruent to angle 6. So angle 1 is congruent to angle 6. I know that angle 3 is congruent to angle 5. I know that angle 2 is congruent to angle 7. And I know that angle 4 is congruent to angle 8. So what I'm going to do now is I'm going to combine all of the congruencies together where all the angles are congruent to each other. So from the first one, I know that angle 1 is congruent to angle 7. And I know that angle 7 is congruent to angle 2. And I know that angle 2 is congruent to angle 6. Okay? So I know all of those together are congruent. Also, I know that angle 3 is congruent to angle 8, right? I know that angle 8 is congruent to angle 4. And I know that angle 4 is congruent to angle 5. Okay? So look at what I want. I want angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. But I have that, right? Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So this implies that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And that was what we wanted to prove. We wanted to prove that the alternate interior angles, right? Alternate interior angles were congruent when these two lines are parallel. Okay? And that is the proof.